data visualization with Python. So for this one, now yesterday during Tianga's session, she used Palmer Penguin dataset. She used the dataset available in the Palmer Penguin R package on CRAN. The package was on CRAN. And for this session, I'm going to use the same dataset. Since you have already familiar with the data set and you have already used it to get data visualization, to do different graphical representations for this data set. So data visualization with Python. Now we have already seen the Palmer Penguin data set, but during yesterday's session, you got access to this Palmer Penguin data set through our package Palmer Penguin. So the Palmer Penguin data set, it was created by Alison Hoare, it was first made publicly available through an R package called Palmer Penguin. And using this Palmer Penguin, now they have developed a Python package for the data, that's for the same data set. So here, using Palmer Penguin's Python package, you can easily load the same data set to your Python environment. So now here I have commented these lines because you have to install it to your Python environment only once. So if you haven't installed, if you are going to work with this Palmer Penguin for the first time, then you need to run these two codes only once. And then after that, you can comment those things. Okay, now imagine you have load. So this allows me to load the Python package, install the Python package. And then after that, you can just use it. So here, from now inside this Palmer Penguin package, I'm going to use only the load penguins function. So I don't want to purchase the entire toolbox. I just want a scissor. So I'm going to use my second format that I explained. So from this Palmer Penguin, I just import this function load penguins. And that function allows me to get access to the Palmer Penguin package. Sorry, data set. So here now from Palmer Penguin import load penguin. So that's the function name. So now Python knows what it is. So you just use load penguin, and that allows me to load that penguin package, penguin data set, and I'm going to save that to an object called penguins. Now, if you want to go and check, now it's like the previous DF. Now, if you want to go and check the first few elements, first few rows of your penguin package, you can just type penguins.head. It will give you the first few elements, first few rows of your package, of your data set. Okay, so here you have already seen this data set. So we have species. There are 3 types of species in this data set. And here we have the location of those penguins. We have bill length, we have bill depth, and we have flipper length and body mass, and their gender type and the year that they have collected this data set. So you have already seen this one. Okay, now let's come to the data visualization with Python. Okay, now yesterday, you learned how to do data visualization using R. The main library that you used during yesterday's session was ggplot2. But when it comes to Python, you will find that there are several popular plotting packages available in Python. So here I have given you some. I have selected 3 popular plotting packages in Python, Plot9, and there's another one called Matplotlib, and there's another one called Seaborn. Now for this session, I'm going to focus on Seaborn, but before that, let me show you how to work with some of these packages. And I will explain the reason for me to use Seaborn for this particular reason for me to select Seaborn for this particular session. Okay, let's start with Plot9. So this is one data visualization package available in Python. So this Plot9 is a Python implementation of grammar of graphics inspired by ggplot2. So yesterday you learned grammar of graphics. Basically, Tianga mentioned that any plot can be explained by 7 layers, starting from data to theme. Now, any part in any graphical representation, you can explain those. There are different layers. So that's what we discuss under grammar of graphics. And the main package, our package that is inspired from this grammar of graphics is ggplot2. And that's why you have these 2 Gs, grammar of graphics, plotting with grammar of graphics. Now, the closest implementation to this ggplot2 is, closest Python implementation to this ggplot2 is plot9. Now, it aims to provide a similar syntax and functionality to ggplot2 in R, allowing users to create elegant and customizable plots. So now you must be thinking, okay, now I have already learned ggplot2. I know the basic syntax of that. So I can now easily use it in the Python environment using plot9. Okay, let's see how to work with plot9 package and get a graphical representation. Basically, this plot9 is built on top of matplotlib library. I will talk about that library in my next part, which is now this matplot library is also a widely used plotting library in Python. But I started with plot9 because you're already familiar with grammar of graphics and you're already familiar with ggplot2. Okay, so this is, let me get the editable version of this one so that I can show you. Okay, so now I have a code. So this is how you created a bar plot using ggplot in R. You started with ggplot call and then you pass the data. Then you need to give the mapping aesthetics. I want to plot a bar chart for this species variable. And then you define the geometry. You want to get a bar plot. And here I want to have it in blue color. And you add here the adding operator, plus operator. And then you add the next layer, labels. X species, I want to have Y count title. Now, so this is what you did with ggplot2. Now, if you run it, let me first run this first. Run this one in Python, you get a small problem. You get an error message. Now, it says invalid syntax and it has pointed towards this plus sign. Now, during in ggplot, you use this plus line to combine different layers, and having it in separate lines allows you to improve the readability of your code. But now it gives me, if you pass it if you run it in a Python chunk, you will get an error message. You can easily ignore this error message if you get all these lines to a single code like this. Now, previously I had it like this. Now, instead of having them in separate lines, if you get all those things into a single line, and that's the only change I did, right? Previously it pointed towards this, but if you get all these things to the single line, now it works properly. Sorry, if you run it, now you can see it works properly. So, but in the previous code, it gave me an error. Now, this is because in Python, here it cannot recognize this as adding a new layer. In plotline, it cannot recognize it as a plus operator that allows you to add a new layer. So, in order to, so what you can do is you can have them in a single line. But now you can see, if you put them in a single line, then the readability of the code is a little bit difficult. But you know, when you work with a programming language, good coding practices are very important. Imagine you work with a group, then the readability of your codes are very important. It's not all about the final output. Only the other developers can read your code, then only they can contribute to it. So the readability of your code is very important. Now it's better if I can have them in separate line, just like in the R implementation. So here it says in Python, if you want to improve the readability of the code and if you want to get them into multiple lines, you can do a small adjustment. You can insert a / after the plus sign. So in Python, this backslash is used as a line continuation character. Because in the ggplot implementation, it knows, okay, after this, you need to go to next line in order to complete that. When you have again plus operator, you need to go to next line in order to complete. But now in Python implementation, plot9, you have to tell R, you have to give some additional guidance. Using a backslash, you can easily do that. In order to improve the readability, you can separate it. Now you add one more additional symbol, backslash. Now if you run it, you can see you get the code. So here it allows me to get the code. So that is the plot9. It's very similar to ggplot2 in R, but you have to do a slight modification if you want to improve the readability of the code. If you want to have them in multiple lines, just use a / to indicate the continuation of the line. Okay, so that's plotline, right? Very similar to ggplot. Okay, another Python library that is another Python graphic library that is very popular among Python communities, matplotlib. Now, matplotlib is one of the most widely used plotting libraries in Python. Now, you can think of matplotlib as the basic plotting library in Python, similar to how base R provide basic plotting capabilities. Yesterday, the younger started with plotting capabilities with base R package. Now, that you can consider this matplotlib as a similar thing. Now, this matplotlib gives you different functionalities to create various types of visualization. Now, this matplotlib is widely used Python data. It's the widely used Python library in the Python data science community. And it has a large ecosystem of tools and packages built on top of it. So let's see how to get the same plot using matplotlib. So now import matplotlib pyplot as plt. I'm going to use that function available inside this package. So one way to do is, now there are two ways to get okay, let me get this one. Okay, it's fine. Okay, now this is how you can use a bar plot. This is how you can draw the same bar plot using this matplotlib implementation. Now, first you need, in order to use the plt bar plot function, first you need to get the counts, or else you can actually no, at the moment just stick with this one. So here what you can do is, I have a penguin data set. Inside this species, I want to get the counts. So this one, penguin species, inside this, I want for this column, I want to calculate the counts for each category. And then here I save that to an object called species count. And now plot plt bar inside this package, inside this function, I have another function called bar. Inside this package, I have a bar plot. So species count index and species count value. So here I have the species count index. Here I have the species count value. So x-axis and the y-axis. And then I assign a proper label to x-axis. I assign a proper label to x-axis as species, proper y label, and then a proper title for the entire plot. And plot show allows me to show the final output. Now you can see here you get the same plot that we got from the ggplot. Now, in most cases, you don't know here let me talk a little bit about this plot show, plt show. Now, in most cases, you don't need to explicitly call this plt show to display the plot, but matplotlib matplotlib library will automatically show the plot when you execute the code. However, in some specific environments or when using a different certain IDs, you must need to include PLT show in order to get the final output. Giving this one is not enough. Sometimes you have to give this part in order to see the output. For example, just let me comment this one. If I run it, now it will create the plot, but you cannot see it. In order to see the final output, you give this last term. Now it gives me this. Okay, so if you're running the code outside the Jupyter Notebook or the IDE, support automatically, but inside Jupyter Notebook, you have to have that in order to see the final output. But there are certain IDEs that allows you to get the output without having this part. But now since we are working with Jupyter Notebook, targeting reproducibility of the research, I have to use this one. Okay, so that is matplotlib. Now you can see we created the same bar plot using plot9 package, and we learn how to create the same bar plot using matplotlib. Another popular plotting library in Python is Seaborn. Now, let's talk about that package as well. Just like R has this additional package like ggplot2 for more advanced and specialized plotting, Python has Seaborn. Plotly and other libraries. Plotly is another package that we are going to explore. Other libraries that allows you to improve the features of a final output of the plots. So Seaborn is closely integrated with now. Seaborn is such advanced plotting library, and this closely integrated with pandas data structures in Python. So that's another reason for us to use Seaborn. And in addition to that, it offers various built-in themes and color palettes. We will see some examples, and that allows you to improve the visual appealing of your plot. You will be able to get aesthetically pleasing plots using Seaborn library instead of using the matplot library. And this actually Seaborn is developed on top of matplotlib library. So you can think it as an advanced version of matplotlib library. Okay, let's see how to get the same bar plot using matplotlib library, Seaborn package. So I have now import Seaborn package. I've given a nickname called SNS. So there are two ways of getting a bar plot using Seaborn package. One is using the count plot. Seaborn count plot, you pass the data, and here you pass the variable where you need to draw a bar plot. So, and then you save that object, save that plotting object to an object called X. And then you can improve some additional features. ax.setTitle allows me to give a proper title to my visual representation. And this allows me to finally show the output in the Jupyter Notebook. So now it has created a nice bar plot for my species. So that's one way to create. I use the count plot inside the Seaborn package. The second method is you can also, there's another plot. Oh, now here you can see with the default setting here with matplotlib, you got it in blue color. But with the Seaborn package, you got it in different colors. If you want to get the exact same thing, then you need to pass the color. You need to pass the color steel blue to get the same plot that you created from matplotlib. So I have done a small addition to this in order to get the same plot that I created using matplotlib. Here I have given color. If you set your color to steel blue, you will get it in blue color. Everything else remains the same, just like in my previous plot. And there's another one. So I use count plot function to create the bar plot. There's another option for you to create a bar plot. You can use bar plot function. But if you're going to use bar plot, then you have to pass. You have to calculate the counts separately, and then you have to pass it. That's why it's easy to, you can easily create a count plot using original data. But if you want to pass, if you want to use the bar plot, then you have to first count the values separately. So penguin species value count, you get the counts for different species, and I'm going to call it as species count. And then, for example, if you just run this one, you can see here you have the counts. This gives me this output. I have this many number of from this category, this many number of penguins from this category, this many number of penguins from this category. Now I'm going to pass that to this seaborn plotting function, bar plot. For x-axis, I'm going to pass the index. So these are my index. And here for the y-axis, I'm going to pass the values. And I want to have them in blue color. And then you can improve the additional plotting features using this. If you run this, here you get the same plot. Okay, so now basically I showed you how to create the same bar plot using 3 different Python implementations. Plot9, it is very similar to ggplot implementation, and then matplotlib, and then so that is, you can consider it as the base R, the plotting functions that you get from a base R. And then we talk about the advanced package called seaborn. All these functions allows me to get the same plot. Now, but I told you during this session, I'm going to focus on I'm going to use the seaborn package as my main plotting library. Out of all these many options, why I have selected seaborn? Here's the reason for that. Now, the popularity of a library. Now, the popularity of the library is influenced by the several factors, including its functionality, ease of use, community support, and historical adaptation. Now, while ggplot is a popular and highly regarded library in the R programming language, its adoption in Python has been relatively limited. Now, these are a few reasons for that. Okay, now you might think, okay, I already know the ggplot2 syntax, so why can't I just rely, and we saw that plot9 has the same syntax. Then you might think, okay, why can't I just rely on plot9? Why should I learn these other matplotlib and seaborn packages? That's because you have to consider the popularity of the package as well in order to select a library. Okay, so here I have given you a few reasons for me to focus on seaborn. So whenever you select a package, you need to think about the popularity of the package depends on these aspects. The familiarity. So matplotlib has been around for a long time and is deeply integrated, and it is widely used in the Python data science community. And many users are already familiar with its syntax, and they have invested time in learning and using. And seaborn is created on top of that, and seaborn has gained popularity for its easy-to-use interface and attractive default style. And the compatibility. Compatibility is also important. Now, the matplotlib is a fundamental plotting library in Python, and it's widely used across different domains. Now, it integrates well with other libraries. So that's what we call the compatibility. How easy for me to combine these functionalities available in different libraries. Now, you have pandas library to work with data frames, and then you are going to pass that data frame to seaborn. Now, the compatibility with different libraries is also important. You need to consider that aspect whenever you try to select a library. And the next one is active community and documentation. The popularity of libraries is often influenced by the size and its active community. Then when it comes to matplot, out of these three, matplotlib, seaborn, and plot9, matplotlib and seaborn are very popular among the data science, Python data science community, because they have been around for a long time. ggplot2, it is a very, compared to that one, this matplotlib, it's older compared to ggplot2. So people have already invested time on that. So they have already used to that one. So it's like imagine two users, Apple users, Android users. If you are familiar, if you are an Apple user, you don't like to shift to an Android phone. If you are an Android user, you will find it a little bit difficult to move to Apple phone. So the same thing happens with this. If you are already used to a certain thing, unless you find some errors or some difficulties with that, you will stick with that particular thing. So that's why this matplotlib and Python have been around for a long time, and they have already got used to that one. And because of that, they widely use matplotlib and seaborn compared to plot9. So this makes easier for new users to get started and find solutions to their problem. So active community is very, very important in order to for the development of that development of the different tools available in that particular environment. For example, now imagine, now here it says familiarity. If I just explain it using a very simple example, imagine you use a basic okay, so the active community and documentation, let me come to that one. Now imagine you use a basic feature phone and all your friends and family use smartphones. Now let's say you lost your charger. You have a basic feature phone and you have lost your charger. Now, and all your friends and family members use smartphones. Now in that situation, now you can't rely on any of your family members or friends. And not only that, these days, everyone is using these smartphones. And if you go to a shop to buy a charger, again, you will find it difficult to find a charger for a basic feature phone, all basic feature phone in the market. So that's what I call. But if you are a smartphone user, then if you lost your charger, then you don't have to worry about it. You can get it from one of your family member or friend, and you can get the thing done. So that's the importance of having an active community. So you can get support from different people. Now, let's say you are a plot9 user and all your friends, collaborators use seaborn. Now, if you get a problem, then you don't have a place, you don't have any member to get a support. So that's why whenever you try to select a package, you have to think about the active community and the documentation. And Python and this matplotlib and seaborn, they have been around for a long time. So there you have a rich documentation for these packages compared to plot9. Okay, so considering all these reasons, the seaborn is very popular among Python data scientists. So because of that, I decided to introduce you to this seaborn library. But you can, since you have already learned, and another reason for me to discuss seaborn library in this session, because you have already learned ggplot2, so you can easily use plot9 to get graphics using the same syntax. So I decided to use this time to discuss another implementation so you can improve your toolbox further. Okay, so now you know the reason for me to select this. Now let's see how we can do the data visualization with seaborn. Any questions up to this? Okay, now let's see how to do a data visualization with Seaborn. Now you know, I'm going to show you how to create graphics using Seaborn library, and you know why we have selected Seaborn library. Now for this particular work, I'm going to use the Penguins dataset, and I'm going to use the Seaborn functionalities. Okay, so let's come to the basics. So when it comes to now in ggplot2, you learn grammar of graphics. That provides the foundation for ggplot2. But when it comes to this one, you don't have grammar of graphics. They have different features, different concepts. They have used different concepts to create this Seaborn structure. So basically, Seaborn divides its plots into the following categories based on the type of the relationship between variables. So these are the main plotting categories that you have in Seaborn implementation. So you have relational plots. So these are the plots that allows you to, under this, the plotting types that comes under relational plots, allows you to visualize the relationship between two numeric variables. Scatter plots, line plots, joint plots. These are some of these things, plots that comes under relational plots. The second category is categorical plots. This allows you to see the relationship between one with numerical variable and one categorical variable. Like bar plots, count plots, there you on the x-axis you have the categories, on y-axis you have the counts. So that's what they mention as numerical variables. And another plotting category that you can see under Seaborn implementation is distribution plot. Now, this allows you to see the distributions of single variables or relationship between multiple variables. For example, the distribute KDE, this KDE stands for kernel density estimation. That allows kernel density estimation method is one method that you can use to get the distribution of a data. And Wiley plot. These are some plots that comes under distribution. Another plotting category is regression plot. So here rig plot, residual plots, this type of plots comes under regression plot. And finally, the last category is matrix plot. These plots are used to display relationship between multiple variables as a matrix. For example, heat maps, cluster maps, these things comes under this category. So basically, these categories provide a comprehensive set of plotting options in Seaborn. Now here, I'm going to introduce you to the basic anatomy of a chart and how you can adjust different attributes of the Seaborn function code. But if you want to learn more about these different functions, here I have given you some additional materials. If you click on that one, it will bring you to the Python graph gallery. And here you have distributional plot. Now, if you, for example, if you want to, now here you can see different types, box plots, histograms, they allows us to see the distribution in different format. Now, if you want to get a box plot, that comes under distribution category, just go to that one. Then it will bring you to this page, and here you can see how to create this plot. You can see an example. So likewise, now I introduce you to 5 categories, distributional plots, correlation. If you want to get, first you can select whatever the format that you need to use and just go inside, you will get access to an example. So here ranking, if you want this type of visual representations, or if you want line or these type of things, and maps, you have so many different options. I'm not going to invest time on all these things. I have provided you enough materials to do the self-study. But let me discuss the basics so that you can do the self-study. You can easily move on to this advanced stuff. Okay, now you know the basic categories that comes, plotting categories that comes under Seaborn implementation. So with that, let's see how to create a basic plot using Seaborn functionalities. Okay. So before coming to the Seaborn syntax, first you need to know the anatomy of a chart, because now Seaborn has different layers, different components. In order to call these components, you need to know the exact name of these different parts of a plot. Now, Seaborn is a high-level library built on top of Matplotlib, which means that many of the concepts and vocabulary used in Matplotlib are still applicable when working with Seaborn. Now, understanding the anatomy of a Matplotlib chart can help you better understand and navigate with Seaborn plots. Now here, I have given you the anatomy of a figure. So just get familiar with these names, because you need these names in order to address these different parts of your, in order to customize or in order to improve these different parts of your plot. So here you have, now here basically these are we call markers, these are we call lines, this part we call a grid, this what you can see here is a legend, and here you can see the title, axis titles, and here you have the X label title, Y label, and then you have major tick marks. These are we call major tick marks. These are we call minor tick marks. Likewise, and these are we call spines. So likewise, just get familiar with the names of these different parts of a figure, because then only you can define, you can change the place that you want to change in your plot. Okay, so now you are familiar with the anatomy of a plot. So now let's move on to creating a plot with Seaborn. So when it comes to Seaborn, the basic steps so there are 5 basic steps that we need to use in order to create a plot with Seaborn. So these are the steps that you need to use in order to create a plot. So prepare some data. First, you need to load the data set into your Python environment. Then you have to control the figure aesthetics. And then you can plot it using Seaborn. And you can do further customizations to your plot. This is where we use Matplotlib. And finally, you can show your plot. So these are the 5 main steps that you need to use in order to create a plot with Seaborn. Okay, so there are 2 ways to create a plot using Seaborn. So the first way, now again, there are 2 ways. I'll explain both methods. The first way, this is actually the recommended way, is to pass the data frame. First, you pass the data frame to an argument called data, and then you pass the column names to axis arguments X and Y. So that's the first method. Pass data frame to an argument called data, and then you pass the variable names to these axis arguments. So data penguins, axis, X is species. So this is how you can do it. Now SNS is my Seaborn package. Inside this, there's a function called countPlot. Seaborn package countPlot. And you pass the data penguins. And here I want to get this countPlot for the species variable. And then I have to show the plot. So this allows you to see the final output plot show. Now it gives me this. So that's the first method. The second way is to directly pass in series of data to axis R. Now there we are going to omit this part, data. The second method is you directly pass the variable to this. Pass series of data to X argument. X, now you don't have this data part here. So you have to, now if you're going to go to this format, first you need to say, okay, penguin, inside that there's a column called species. You give everything at once, so I want to have it on the x-axis. Again, it gives me this. But the recommended way is the first one. You pass the penguins into the data frame, into the data argument, and then you pass the aesthetics to the other arguments. Just like the same thing you did with ggplot2. First, you pass the data set to an argument called data, and then within aesthetic, you map the columns of the data frame to each of the aesthetic. Okay, so this is the recommended way, but you can still, this also allows you to get the same thing. But now the readability of that one is a little bit difficult, a little bit low compared to this one. You can clearly say, okay, this is your data, and these are the columns that you need to map to these axes. Okay, now you know, since this is the recommended format, I'm going to stick with that format. So now let's see how to do different visualization using this. So you will see, so basically you have seen most of these plots during most of these outlooks during the ggplot2 yesterday's session. I'm going to explain how to get the same plots using this Python implementation, using this CBOM package. So let's say you want to create a scatter plot. You want to create a scatter plot for flipper length and body mass. Now here, SNS scatter plot. So inside this SNS CBOM package, I have a function called scatter plot. First, you pass the data set to the data argument, and on x-axis, then you do the mapping. Here I say, okay, take flipper length inside this data penguin package, take flipper length to x-axis, take body mass index to y-axis. And finally, you show the plot here, it gives me the scatter plot. Now let's say, so this, by default, it gives me this blue color. Let's say you want to assign, now I have 3 species inside this data set. Let's say you want to color these values according to the species. That's what we call mapping colors. Basically, under mapping, you try to assign, and you try to map each of these points to another, to each and every species. So let's see how to map colors according to a variable. Just like you actually saw this under mapping layer during yesterday's session. So SNS scatter plot, I have data. So this code up to this first 3 elements allows me to get this. But now I want to map a color to each of these points according to the species. And you can easily do this with this hue argument. Now this hue argument, this one allows me to this hue argument determines, okay, which column in this data frame that I should use for color encoding. Hue argument explain, okay, it tells this function call, okay, use this variable to map colors to each of these points, hue. And you can also give a separate, instead of having all these points as dot, you can also assign a separate style to each of these categories. So then once the advantage of having different styles is if you get it, now here you have a colored plot, but imagine you get it in black and white print. Even though you give us different colors, sometimes it will not be visible properly in the black and white print. Now, you can easily avoid it by assigning a different shape to each of these points according to the species. So now here you basically map the species to the color and also to the style. And now it allows me to get this plot. Now, I will give you, if you want, you can just, I will give you maybe 3 minutes if you want to try your own plot. If you would like to draw your own plot, maybe you can just try it out. So first you need to load your penguin data set. and then you need to load the Seaborn package. And then you can just call the function SNS scatter plot. You have data, you pass x-axis variable, y-axis variable. In addition to that, you can also map colors and styles according to the variable species. Okay. So now basically in my previous example, I just map a color to each of these points according to the species. And you can even, just like yesterday's session, you can even give expression to define a subset. Instead of using this type of categorical variable, you can give a expression and define a subset. So I have my data penguins. On x-axis, I have flipper length. On y-axis, I have body mass. And now here, I told you this determines which column in the data frame should be used for the color encoding. Now here, instead of using a categorical variable, you can define this type of an expression subset. Penguins flipper length less than, I want to color I want to define two subsets. One is penguins with small flipper length, the other one penguins with large flipper length. So here I have just given two colors. Now here I have 205. So for this group, I have given one color. For this group, I have given this color. Okay, so mapping, you can also map this type of, you can also create scatter plots using this conditional coloring. Okay, so that's mapping. Basically, you use another variable to decide the color of these points. That's what we call mapping colors. We map each and every point according to another variable of my data. The second type that you can do is setting colors. Instead of mapping each and every point, instead of mapping, they can just set a color. They can just give a color to all the points. So you have data penguins, X flipper, and here you now previously you use hue. I told you hue.
Priyanka,
yes.
Are you changing this? Are you doing any coding? We can see only the scatter plot between body mask and flipper length.
No. Can you see the scatter plot with the purple color dots?
No, we can't.
Okay, then let me stop sharing. Or maybe. Now, can you see my screen?
Yes.
Okay. Okay, can you see the plot with the purple color dots?
Yeah.
Okay. Any questions up to this before I move on to this setting color? Okay. So as I explained earlier, now hue argument allows you to decide which column in the data frame you should use for the color encoding. There you basically refer to a variable. But if you just want to set the color, then you can use the color argument instead of hue, because now you don't have to do the mapping. So here, if you want to just set all these dots in purple color, if you want to color all these points using purple color, just use the color argument and purple. And now you have set a color to all the points. Now it doesn't involve any mapping. So that's what we call the setting colors. Okay. Then we can think about adding layers. So yesterday, you talked how to add multiple layers on top of each and every layer. You started with box plot and you learned how to add a distribution plot on top of that. We can do the same thing using Seaborn implementation. So here what you can now there, in order to do that one, you add all those layers using plus operator. In ggplot2 implementation, you add all those operators using plus. But here you don't have to have that type of a thing. What you can do is, now let's say I want to, now this is my scatter plot. I want to give distribution of plot, distributions. I want to see the distribution of each and every category. So you can easily do that one. The first argument, SNS scatter plot, this allows me to get a scatter plot, this one. So, okay, let me just remove these two. And let me show you this. Okay, if I just run it, this is what I get. On top of that, I want to add the kernel density. I want to calculate the densities of each of these. Then you add the second layer like this, SNS, KDE, you pass everything. Now here, if you run, now I have two layers. Now if you run it, your final output shows like this. Now you have the scatter plot. In addition to that, you have this distribution as well, distribution of the entire data set. Okay, so that is what how you can do this adding layers. In ggplot2 call, you use plus operator, but here you don't have to connect them like that. Just give them one after the other. Then it knows, okay, I should add all these things before plotting my final out, before producing my final out. Okay. The next one is scaling. Now, yesterday you learned how to control, how to change these different parts of your plot. So that you can easily do. Now here, if you just run this part here, scatter plot data penguin, this basically specify the data frame, specify the x-axis variable, y-axis variable, and now hue and style allows me to do some changes to the original plot, the default plotting options. Hue allows me to color the points based on species. Style allows me to use a different point shape based on the island. Now that allows me to get this type of a nice plot. If you use two different things for species, I use these colors. For islands, I use these objects, then you get a legend like this. If you use for both cases, if you just use, now in this case, if for both hue and style, if you use the same variable, you get a legend like this. But now in this plot, I just use for species, for the color, I use species. For the style, I use a separate variable. So as the final legend, you get it like this. Okay, and now here, if you just pass it like this, here what you get the things with the default setting. But you don't have to stick with the default setting. If you don't like the default colors or default shapes, you can define you can do it, you can change it manually. Here, for example, if here this gives you the this has used the default color palette. But if you want to change the color palette, here you can say palette. Here you can define your own color. Here what you have got here, you have got 3 different colors, and that comes with the default setting. But if you want to assign your own colors to each of these categories, then you can define your own color palette like this. So first you define a color palette. So here, this is how you define a color palette. Colors equal, within curly brackets, I have now 3 species, Adelaide. So Adelaide, I'm going to give red color. Chimstrap, I'm going to give blue color. Gen 2, I'm going to give dark green. And now here, and now I have defined them in this format. I have just, this is my first one category, comma, second category, comma, third category. And now I have enclosed them using a curly bracket. What you call, this is we call a dict class, dictionary class. In Python, this dictionary class, I'm sorry, I've done a change. In Python, these dictionaries are one of the fundamental data structure in Python. Now, basically, we use dictionaries to store keys and value pairs. So basically, these are your, when it comes to keys, you have unique key, Adele, Chimstrap, and Gento, they are keys, and you have given a value for each of these keys. Now, by doing this, from this syntax, you can define a dictionary. We call this as a dictionary. Basically, it allows you to store these key value pairs. And now this is my color, and I have saved that to an object called color. So previously, I got these colors according to the default setting. If you are not happy with that, now the remaining part of the plot remains the same. So here you can just pass the colors. Palette equal colors. Use the user-defined color palette. And now I gave red color to Adelaide, blue color to Chimstrap, and dark green to Gen 2. And here I have got it in my user-defined colors. So you can take the control of the colors of the point. How can you do that? You can define a dictionary. You can define this type of a dictionary. So these things we call keys. Adelaide, Chimstrap, Gen 2, they are we call keys. And these red, blue, dark, green, they are values. Keys are always unique. We have 3 different categories, Adelaide, Chimstrap, Gen 2. And you can assign a value to those things using a colon. Okay, so, and not only that, now here, for hue, I use, in order to assign a color to each and every point, I use species or categorical variable. But you can even use, continuous variables or numerical variables to assign a color. So here, basically, instead, you don't have to have categorical variables all the time. You can, if you just give a numerical variable, you will get the plot like this. Okay, and here you can see, here you have very light colors. Here you have the dark colors. Here I've colored them according to the bill length. When you have smaller flipper length, you tend to get a smaller bill length as well. When you have large flipper length, you tend to get large bill length as well. That's what you can observe from this graph. And here, now basically, now I define the color palette, but you can also, now there are some built-in color palettes as well. You don't have to define. Now imagine you have large number of categories, then defining your all color palettes are a little bit difficult. In such situations, you can use a predefined color palette. Yesterday, Tianga introduced you to Color Brewer package and Viridis package. The same functionalities we can get through this Z1 implementation. So here, if you want to use a predefined color palette, what you can do is, previously I just gave a user-defined color palette. I just define my color palette as colors, and then I assign it here. But if there are some predefined built-in color palettes, you just replace this palette from a predefined color palette, dark 2. I hope you can remember the dark 2 color palette. It comes under this Color Brewer color palette. Then it gives me nice colors. They have assigned nice colors to each of these categories. And if you want to, now here I use dark 2. If you want to see all these color palettes available inside this Color Brewer, basically Color Brewer is an online tool designed to help people to select good color schemes for the graphs. Selecting a good color palette is also very, very important. If you can't think of some colors of your own, on your own, then you can use Color Brewer package to select a color palette. So you can see all the options available inside this Color Brewer. So import Brewer to MPL package. Inside that, there's a print map that allows me to see all the color palettes, names of all the color palettes, and I use Dark 2. Dark 2 is one such palette that is available through this Color Brewer palette. So I just use Dark 2. If you use another one, let's say set 1, if you just use set 1, and let's see what happens if you just set it to set 1 color palette. Here you get in different color. If you make it to set 2, another color palette that comes under this Color Brewer, you get this. So likewise, you can just think you can just pick a name for the color palette and you can replace it from here. So basically, these Color Brewer color palettes provide sequential, diverging, and qualitative color palettes. And yesterday, Tianga introduced you to another color palette called Viridis. Viridis is another one that I commonly use for my work. So here, if you want, you can even change this to Viridis color palette. So then it will give me like this. So Viridis is one common color palette that I use quite frequently. So one reason is both this Viridis and our Color Brewer provide color-blind friendly color palettes. Now it's very important to consider all these things when if you want to do effective data visualization, you have to do all these aspects, because you use data visualization to improve the understanding of a given context. And using a proper color palette is also important. Now, this Viridis and Color Brewer, the advantage is they are colorblind friendly color palettes. Because when it comes to my classes, sometimes there are students who are suffering from this color blindness. Then they will not see the exact color that you have used to create your plot. And sometimes if you are going to write a journal article, then your audience can also, some readers will be colorblind. So in such situations, selecting a colorblind friendly color palette allows them to understand the context without having any difficulty. And another advantage of this Viridis is it is designed in such a way that it is easy to read both in a regular form and also in black and white version. So imagine you print this one, then you can easily differentiate. Imagine you print this document in a black and white printout, then you can easily differentiate these dots without having any problem. Okay? And this is, and sometimes this is a common requirement by some of the journals. You can use color figures, but you should be able to differentiate them in black and white printouts as well. So whenever I write a journal article, I consider all these things, all these aspects when I try to produce figures for my journal articles. Most of the time I use Viridis for these obvious reasons. These Viridis and Color Brewer provide different color scales that are robust to color blindness. And for details and interactive palette section, you can also go to this Color Brewer package, this one. Here, this actually shows you different color palettes, sequential, divergence, qualitative. You can select a suitable color palette for your visual representations. And it's not only the color, you can also control other scales, other mapping elements of your package, just like you did with ggplot2. So if you are not happy with the default settings, you can take the control of those different aspects. For example, now here, when it comes to x-axis, this is they have given this type of a breakdown. But let's say you want to control that. So basically, this part allows you to get this basic plot. Now I have used palette, plasma, style, species. And if you want to control these breakdowns, these minor tick marks, then you can define your own breakdown. So this is how you can do it. Plot X ticks 1, and I'm going to have only 3 tick marks. X ticks. So if I want to highlight one more thing, why I introduce you to this these anatomy of a matplotlib function. Now here you can see these are we call major tick marks, minor tick marks. So you need to know the exact name that we use to refer to these attributes. Then only you can use these functionalities, right? So here, PLT X tick 170, 200, 230. Now it allows me to get the control of the breakdown of my x-axis. If you don't pass that one, it will go to the default setting and give you this breakdown. If you want to, now here I have it, I get my y-axis on the original scale. But if you want to get them in log scale, then you can just plot y scale log. Then it gives me this. And let's say you're not happy with, now if you just give these things, now if you just pass another thing, if you just style, for style, I ask it to use the species so that it can give different symbols for each species. Let me show that one. So basically here, I ask it to give the style. Sorry. In this one, I ask it to give the style, give a different symbol for different species, different symbol for the different species. Now it selected a circle to Adelaide, this cross to Gento, and this square to Chimstrap. But let's say you are not happy with this default setting. Then you can take the control of those symbols. You can define your own shapes. You can easily do that using this type of a marker. So here, let me see that one. Okay, I'm sorry. Here you can easily do that one like this. So if you come to this one, so you have the data penguin, you have the flipper length, body mass, and here you need to determine which column in the data set you should use to give the color, do the color encoding. I'm going to use species, and for the style I'm going to use the species. I want to give a different symbol for each and every species. And then I'm going to use this color palette. But I'm not happy if we just pass only these things, it will select its own symbols for each and every category. But let's say you are not happy with the default setting, then you can easily assign different symbols using this option mark. So again, I have used a dictionary object. For Adelaide, I'm going to give S, square, S stand for square. For Gento, I'm going to use a circle. For Chimstrap, I want to give a triangle. And if you give it like that, now for Adelaide, they have used a square. For Gento, they have used a square, a circle. For Chimstrap, they have used a triangle. So likewise, you can take the control of these default settings using a marker. And everything else remains the same. Any questions up to this before I move on to facet? Okay, now let's see. Yesterday you also learned about the faceting. So basically, now here also we have the option to do the faceting. So basically, this facet create a separate, allows you to get the same plot for different subsets. So basically in faceting, what you do is you divide the data into sub-series. You divide the data into subsets, and then you define the panel. Then you get the same plot for each of those plots, the different subset. You get the same type of graph for each subset. That's what we call faceting. So here basically I have 3 groups, Adele, Gento, and Chimstrap. So now these are my subset. I want to get a scatter plot, separate scatter plot for these 3 groups. So faceting allows you to get the same type of plot. Now here it's a scatter plot for each subset. So we can easily do that one, SNS, facet grid, penguin, and here for the columns, so SNS, facet grid, penguin, columns. Now this basically allows you to create the plotting panel. SNS, facet grid, penguin, I want to define for each column, I want to get a part of this species. Now then, for each panel, now I have to map this plot. So SNS scatter plot, mapped SNS scatter plot. For the x-axis, you have flipper length. For the y-axis, body mass. So basically what you say is plot, give this type of a plot, scatter plot, where x-axis is flipper length, y-axis body mass, and give that type of a plot for each and every category of these species separately. And I want to define these categories, different categories column-wise. And now here it gives the plot. So now you can see this is the scatter plot for Adelaide, this is the scatter plot for Gento, this is the scatter plot for Chimstrap. Now you can see that each plotting panel uses the same underlying logic, only the data is different. And now create scatter plots using Seaborn and facet wrap. So now here, there's another way to do that one. Now here, basically, I define the plot, I break down this entire plotting panel into 3 columns according to the species category. Now these columns was defined by this species. But let's say inside this species, let's say you have 10 categories, 10 groups. Then you will get 10 panels on the same, which will make it a little bit difficult to see the visual representation. So in some situations, you can use column wrap so that you can break it. So basically, it's the same thing. SNS, facet grid, penguin, I define my columns according to species. Let's say you have large number of categories inside this species, then you will get large number of columns. In order to avoid that, you can use the column wrap. And another thing that you can use, you notice is, now here when you just go with the default setting, you will get the same, the same x-axis limits and y-axis limits. You have a common range. You have a common range for the x-axis and y-axis. You can easily change that one. You can free using share x false, share y false. Share x false, share y. And then this basically you define what type of a plot that you need to have in each and every plot, and plot show, now it gives me this. So now you can see one thing that you can notice is previously I had a common range for the x-axis, but now you ask it not to share the common range. So I set that to false. Now you get different range for each panel. Even for y-axis, I ask it to not to use the same range. So now you get it in different. You get different ranges for the different panels. And another thing is I introduce you to this color wrap. So basically, this is what happened. So column, the species define the columns. But if you have 10 columns, let's say now I have only 3. So that's why you got it like this. But if you just give it as column wrap 2, this is what happened. So it only gives that number. Now this controls the number of columns. So I have my first column, second column, column wrap. I ask it to go to the next column after that. If you set that to 1, and see what happened is, okay, if you set that to 1, okay, I have first column wrap. I ask it to have only 1 column here, and then go to the next one, and then go to the next one. If you just set that to 3, that means basically you only have 3 categories. And facet grid. So basically now, yesterday Tianga mentioned facet wrap and facet grid. Facet wrap is to define, we use in our ggplot2, we use facet wrap if you have only 1 categorical weight. We use facet grid if you have 2 categorical weight. But in the Seaborn implementation, you don't have 2 separate things. You still use the same functionality, facet grid. Here, facet grid, if you have only 1 variable, you just pass it on the column variable. But if you have 2 variables, if you want to define this type of a facet grid, if you want to define panels with respect to categorical variables, you can just pass it, one for the column variable attribute, the other one for the row attribute. Now it gives me a grid. So here on this side, I have the species. On this side, I have the gender type. And now it gives me a facet grid. So here now you can see basically now it defines subset according to both column and row. So this is male Adelaide. This is male gender, male chimstrap. This part represents female Adelaide. This part represents female gender. This part represents female chimstrap. And now I get a separate plot for each and every subset. And another thing is the coordinates. You can also get the control of the coordinates. Now here, if you want, now here, if you just part is like this, SNS count plot. If you give your species to x-axis, then you get the species here and give the coordinate bar plot like this, a vertical plot. But let's say you have, sometimes you prefer to have a horizontal bar. The only different you can do, the only thing that you need to do is instead of assigning the species to X, you can assign it to Y. Now on the Y-axis, it takes the species. In our implementation, you have code flip. But here in this one, you can easily do it by assigning it to the different attributes.